On 4B, we have a base. It is methylamine. And you would be given the formula of this if you needed to know it. That's the formula right there. But with this, we could also just write this in terms of a generic equation. We've got a base, and then the base when it has gained a hydrogen plus ion. So writing the KB isn't required based upon what's asked, but on most acid-base equilibrium problems, if it's free response, you'll either be given the KB or that'll be something you'll be asked along the way. So when we think about this, we've got KB is our x squared over our molarity. We can also see that right here from our rice table. We have a certain, we've got our base. It turns into the protonated base, or the base with the H plus, which then turns our water into the OH minus. So notice that this isn't totally balanced because I've left out the water molecule. But once again, that doesn't get included in our equilibrium expression, so that's okay. We've got our molarity minus X, but relative to this amount, that is quite a bit larger than that, 1 versus 0.0004, which is why we can do our estimation that it's about equal to 1 in that case, and then x squared on the top. So once again, K is equal to x squared over molarity. A really important thing to note and to think about or remember here is that the X, when it's a KB, comes out to our hydroxide ion. So then when we're asked about pH for a weak base, or even a strong base, but in this case weak, we have to remember we have to do 2 steps, either find the pOH and change that to the pH, or the way I normally do it is take our OH concentration, turn it into our H plus concentration, and use that to find our pH. Remember, as you are doing any of these problems, it's in addition to good practice of doing all of the steps, it's a great chance to do some practice with your estimation of pHs. So since this is 4 to the negative 13th, that's our clue that our pH will be between 13 and 12. So we don't need to know the exact value between 13 and 12, but it should make sense that a pH of 12 point something is our answer. The other thing, we could have done it on the last one, and we'll see on some others, to show that the minus X doesn't really matter, that 1 minus 0.02, in terms of sig figs, that would round right back to 1. So that's kind of the idea here. We could think about it, how much bigger is our molarity than our K, look in the book or online and find out about the 5% rule, or just recognizing that subtracting this in terms of sig figs really doesn't significantly change that, which is our support kind of after the fact that our estimation was really good.